Hello everyone. Today I will discuss properties of definite integral. Number one, first property. A to B, integration A to B, fx dx equals A to B ft dt. This property means if the limits and the function, these are the limits of upper limit and lower limit, and the function of the definite integral do not change and only variable changes. You can see here variable is x and here variable is t. Then the value of definite integral remains the same. Means if we are not changing limits, we are not changing function, only variable is changing, then value of the definite integral remain the same. Let's see its proof. We can see taking LHS, say it is A to B fx dx. Suppose the antiderivative of fx is capital Fx and limit is b to a. That is fb minus fa. Say this is equation number 1. Now taking RHS. RHS is A to B ft dt. And say the antiderivative of ft is capital Ft. And limit is b to a. It would be fb minus fa. Say this is equation number 2. From equation 1 and 2, we get LHS equal RHS. From equations 1 and 2, we get LHS equals RHS. That is A to B fx dx equals A to B ft dt. We can also prove it in another way, like second method. This is first method and second method. Taking LHS is A to B fx dx. Let's assume over here let x equals t. So dx would be dt. So it will become ft dt. And on changing the limit, as x tends to a implies t tends to a again. And as x tends to b implies t tends to b. The limit will remain same. That is equal to RHS. In both ways we can do it. Let's take example. For example, we have 1 to 4 x dx. Find out its value. Antiderivative of x would be x square upon 2. And limit is 4 to 1. So 1 upon 2, it would be x square and 4 to 1. That is 1 upon 2, 4 square minus 1 square. That is 16 minus 1, 15 upon 2. Now let's take 1 to 4 t dt. Its integration would be t square upon 2, 4 to 1, that is half t square, limit 4 to 1, 1 upon 2, 4 square minus 1 square, that is 15 upon 2. Say this was your equation number 1 and equation number 2. From 1 and 2, from equations 1 and 2, we can say limit 1 to 4 x dx equals limit 1 to 4 t dt. Let's take one more example. 0 to pi by 2 sin x dx. Its integration would be minus cos x and limit is pi by 2 to 0. That is minus cos pi by 2 minus cos 0. Cos pi by 2 is 0 and cos 0 is 1. So minus 0 minus 1, that is 1. Say this is equation number 1. Now taking 0 to pi by 2 sin t dt. It would be minus cos t 0 to pi by 2, that is minus cos pi by 2 minus cos 0, that is minus 0 minus 1, that is 1. From 1 and 2, from equations 1 and 2, we can say limit 0 to pi by 2 sin x dx equals 0 to pi by 2 sin t dt. Now the second property. Second property is also known as, this property is known as reversing the interval. Reversing the interval. What is its meaning? Means a to b fx dx equals minus a to b fx dx. What is its meaning? We have reversed the intervals. This property means if the limit of the definite integral are interchanged, I have interchanged the limits a and b, then the value of definite integral become negative of what it was. Suppose its value is x or its value is, for example, its value is delta, then its value will be minus delta. Let's see its proof. A to b taking LHS. Taking LHS. A to b fx dx. Say antiderivative of fx is capital Fx and limits are between. It would be fb minus fa. Say this is equation number 1. Now, or we can simplify it further, or taking RHS. RHS is minus a to b fx dx equals minus as it is, and say antiderivative of fx is capital Fx. Limit a to b. That is minus fa minus fb. That is on multiplying with minus sign fb minus fa. Say this is equation number 2. From 1 and 2, we can see we are getting the same result. From equations 1 and 2, we can say a to b fx dx equals minus a to b fx dx. The name of this property is known as reversing the interval. What is its geometrical meaning? For example, I draw the graph. Suppose I have this is x-axis, this is y-axis, and say the graph. Suppose I take any graph like this graph I'm taking, and this is origin, and this area. If I take B to A, then it will become minus. If I'm taking A to B, then it will be positive A, and if I'm reversing its limit, then it will become minus of A. Let's take example based on it. I'll take the same example. For example, I have 1 to 4 x dx. Then its integration of x will be x square upon 2. I'm taking the limit 1 to 4. Half, that is 4 square minus 1 square. That is 1 by 2, 16 minus 1, that is 15 upon 2. Now, on interchanging the limit, let's take 1 to 4 x dx. What will become? Its integration would be x square upon 2, 1 to 4, that is half, 1 square minus 4 square, that is half, 1 minus 16, that is minus 15 upon 2. And what is the value of 15 upon 2? I have 1 to 4 x dx equals minus 15 upon 2. Substitute the value of 15 upon 2 from equation number 1. It is 1 to 4 x dx. The value of 15 upon 2 is equal to 1 to 4 x dx. So we conclude that on interchanging the limit, value remain the same, only its sign changes. Let's take one more example. Zero to, say I'm taking 0 to pi by 2 cos x dx. Integration of cos x would be sin x and limit. That is sin pi by 2 minus sin 0. Sin pi by 2 is 1 and sin 0 is 0, so it is 1. So this is equation number 1. Now on interchanging the limit, cos x dx equals integration of cos x is sin x and substitute the limit. It would become sin 0 minus sin pi by 2. Sin 0 is 0 minus 1, that is minus 1. That is 0 to pi by 2 cos x dx equals, and it is minus 1, minus will remain as it is. Substitute the value of 1 from equation number 1. What is 1? This. That is 0 to pi by 2 cos x dx, 0 to pi by 2 cos x dx, or you can also write it like this, 0 to pi by 2 cos x dx is minus of, by multiplying both side by minus sign, it would be 0 to pi by 2 cos x dx is minus of 0 to pi by 2 cos x dx. That's all in this video. Thank you so much.